All right, this is day 10 of solving math problems until a whole life member notices me. So pretty much here we have a trigonometric equation where we are pretty much asked to solve for all x. But the thing is, we're not going to just use basic squaring and converting everything into sine or cosine. We're pretty much going to go ahead and use the tangent double angle identities. So pretty much like the tangent double angle identities are we have pretty much something, let's say v is equal to tangent x over 2. And pretty much sine and cosine pretty much are going to depend off of tangent x over 2. So we have here 2v over 1 plus v squared. And cosine of x is equal to 1 minus v squared over 1 plus v squared. So pretty much we're going to go ahead and just plug everything in right here. So we have 1 minus v squared over 1 plus v squared plus, and then since we have cosecant, we're going to just flip the sign around. So we're going to have 1 plus v squared over 2v, and that is equal to 1. And what we're going to do is simply just get rid of the denominators. So we're going to first multiply by 1 plus v squared and 2v. So here we're going to have 1 minus v squared times 2v plus 1 plus v squared. And then since that is multiplied by 1 plus v squared, that's going to be squared. That is equal to 2v times 1 plus v squared. And pretty much what we have now is a simple expression right here where we could expand everything out. So we're going to have 2v minus 2v cubed plus v to the 4 plus 2v squared plus 1, and that is equal to 2v plus 2v cubed. And we're going to have a fourth degree polynomial, of course, like namely, so we have v to the 4 minus 4v cubed and plus 2v squared. And we have 2v, so they're going to cancel out. And we're going to have plus 1, that is equal to 0. So here we could go ahead and take the long way, which I will not do for now, which will be pretty much a future video. But what we're going to have is we're just going to say that v equals 1. So that works because we have 1 minus 4 plus 2 plus 1, which 1 plus 1 is 2, 2 plus 2 is 4, 4 minus 4 is 0. So pretty much we have a simple quartic, which we are going to honestly factor out a v equals 1, which pretty much we're going to just do synthetic division, and we have 1, and then 1, and negative 4, 2, 0, 1. As you relate to the polynomial's coefficients, we're just going to drop down the 1, and then we're going to multiply 1 by 1, so which is 1, and then add from top to bottom, so it's negative 3, and then multiply negative 3 by 1, and negative 3, which is negative 1, and then multiply 1 by negative 1, negative 1, negative 1, and negative 1, and 0. So pretty much we have our expression v minus 1 times v cubed minus 3v squared minus v minus 1. And pretty much now that we have a cubic, we're going to go ahead and solve this cubic, which this cubic unfortunately does not have a rational root. So we're going to solve it using pretty much Cardano's method or just any other method. So we have v cubed minus 3v minus v minus 1. And pretty much here we're going to set, or 3v squared, we're going to set v equal to y plus 1, where pretty much we're going to center it at 1, and we're going to use just the Taylor series instead of plugging everything in. So we have f of v, which is f of 1, and that is going to be equal to -4, because 1, -3 minus 1 minus 1, the 1's cancel out, leaving -4. And the derivative f prime of 1 is going to be 3v squared minus 6v minus 1, which is just going to be 3 minus 6 minus 1, which is just going to be -4 as well. So we're going to have y cubed minus 4y minus 4. So now we're going to solve this cubic, and here we're going to just simply have y is equal to the cube root of u plus the cube root of t. And we're pretty much going to impose the conditions u plus t is equal to 4, and uv is equal to pretty much 4 over 3 cubed, which is 64 over 27. Yeah, and I forgot to set equal to 0, all of this, which is pretty much important when we were solving an equation. So pretty much here we will have u is equal to 64 over 27t. And what we will have now is to plug in u into the first equation, which will give us 64 over 27 plus t squared is equal to 4t. And t squared minus 4t plus 64 over 27 equals 0. We're just going to complete the square, so we have t squared and then minus 4t plus 4 and minus 4 plus 64 over 27. And this will just be t minus 2 squared, and then plus 64 minus 108, which is going to be negative 44 over 27, and that is equal to 0. And we're going to add it to both sides, so it'll just be equal to that. And t is going to pretty much be equal to 2 plus or minus root 44 over 27. And pretty much now we could go ahead and plug everything in to find y. And we're going to get that y is equal to 4 over 3 times the cube root of 2 plus root 44 over 27 plus the cube root of 2 plus the square root of 44 over 27. And since we're going to find v, we're just going to go ahead and add 1. So pretty much we have v is equal to 4 over 3 cube root 2 plus root 44 over 27 plus the cube root of 2 plus the square root of 44 over 27 plus 1. And to find the other three solutions, we just use the roots of unity, which I will list pretty much all our solutions up here. So yeah, let me just clear that up. So pretty much our roots will be v is equal to 1. Well, I'll just list them all in terms of tan. So there will be tan of x over 2 is equal to 1, and tan of x over 2, tan of x over 2 and tan of x over 2. So the first one, we found out that it was 4 over 3 times the cube root of 2 plus the square root of 44 over 27 plus the cube root of 2 plus the square root of 44 over 27 plus 1. And let me just move these down a little bit. Tan of x over 2 is equal to 4 over 3 times the cube root of 2 plus the square root of 44 over 27 times e to the 2 pi I over 3 plus the cube root of 2 plus the square root of 44 over 27 e to the negative 2 pi I over 3 plus 1. And the other one, I'll just copy it down. Let me just get rid of this little thing and leave it up. And what we're going to do is just simply change the signs. So it is swapped. So pretty much like here now we're going to have our just the last steps, which are going to just be taking the inverse tangent of both sides. So I'm going to go ahead and do that. So pretty much we're going to start off with the first one is going to be x over 2 equals to pi over 4, since we know that tan inverse of 1 is just pi over 4. So here we could just say that x is equal to pi over 2 plus 2 pi. And here we're going to simply have just 2 times tan inverse of all of this plus 2 pi, and then it will be 2 tan inverse of all of this plus 2 pi, and then adding 2 pi to the last one, we will have pretty much the tan inverse. And pretty much these will be all our solutions for x, where we just simply have these expressions that are, well, let's just say beautiful. And yeah, this is kind of a pain, but you know, it's something, all right. So yeah, hopefully this was fun watching, even though I kind of just sped through this. But yeah, hopefully you guys enjoyed it. And yeah, this is where I say bye-bye.